Hey guys, this is Ron Vadum with Atlanta Functional Programming. Today we have Elijah Malaby giving us a little introduction to Screamer and non-deterministic programming in Common Lisp. So without further ado, Elijah, take it away.
Okay, so Screamer. A couple things to sort of set us going. First one is that even if you may never actually use non-deterministic programming in a project, you might. I have, done a couple of projects with Screamer in the past. But even if you don't, I do want you to see one thing which is rather important, which is how tightly Screamer is integrated into the rest of Common Lisp as a whole, and how it is able to leverage so much of the existing, Common Lisp ecosystem, while still effectively, changing at a very fundamental level how evaluation happens and how control flow occurs, to give you I guess you could say, axis of movement that you wouldn't normally have, which I'll explain very soon. My point though is that while Screamer is a very, very cool library, it is a rather weird one, and one that embraces a style of programming that I don't see very many people making great use of. And so just for people who are wondering even if they'll ever use something like this, pay attention if only to really get the feel of a library that is this different, but still so well integrated into Common Lisp as a whole. Because it really sort of shows what you can pull off with a few bits of macro magic, and a code walker. But that's for another day. So Screamer is this really interesting library that allows you to program in a style called non-deterministic programming. And non-deterministic programming, what that basically means is you have functions that are allowed to have multiple valid results, in a sense. There are multiple perfectly valid things that function could return. And there isn't really a right one a priori, right? We don't know ahead of time which one is the correct return value. Later on, we may discover that the return value that we got wasn't actually the best one or the right one based on other constraints that we've learned in our program. And in that moment, we can, use this really fun operation called fail, which it, conveniently errors at me because I haven't made any, I haven't set up anything that it can recover the failure from. You can use a thing called fail, and what'll happen is it'll rewind back up to that, that function that could have returned a couple of different possible things. It'll tell that function, hey, pick something else, and then redo all of that code that we just ran, and see if that was the right one. And so this is a very interesting sort of approach to working with code. It leads you to have fun things like, functions like an integer between, right? Which is an integer between here, which does this fun thing where it, I'll explain this in a second. One value, an integer between, 5 and 200, well, it'll pick one. And it'll say, well, 5. 5's an integer between 5 and 200, right? But I can then do something fun, which is I can say, let, x be an integer between 5 and 200, right? And then say, I can assert that not equal x5. So x can't be 5. And now we'll return x, and it'll say 6, because 6 isn't 5, and 6 is an integer between 5 and 200. And so what happens there is it picks an integer, it goes forward, it discovers that it can't be 5, and if it was 5, it undoes that work and goes back and picks a different integer. And when it picks one that isn't 5, it'll continue forward, and it'll return that integer. In this case, we got 6. You'll notice that I had to wrap that in this thing called one value. And the reason for that is you have to get back to nice deterministic programming eventually, because you don't really want your functions to be returning multiple possible things, and really what that is one value is sort of the place where Screamer can sort of take control of all the code inside there and rework it so that Screamer can actually do its magic rewinding. And so you need to use one of Screamer's forms. There's one value is the one that I'm using here, which is sort of gives you one of them, the first one that it comes up with. There's also all values, so you can do all values, an integer between 1 and 10, and we'll get this nice list of all of the integers that particular non-deterministic operation could possibly come up with. You also have ith value, which, as you can imagine, takes an index and gives you back. And part of the idea is that there is actually an order here. You do actually have an ordering of the return values, and so you can trust that when you run this code multiple times, you will actually get them out in particular order. But subtle changes to the code could definitely drastically change that order. So it's a sort of, there is some determinism and some not, and part of it's implementation details and part of it isn't. But it provides this sort of very interesting way of phrasing your problem. Really, you get to sort of start with these very general ideas about what you need, and then refine down to the very specific thing that you need, and then let Screamer just sort of figure out the thing that satisfies all your requirements. And so, does that sort of, are you guys following me so far? It's a little weird, I must admit.
Just a question on this ith value. Well, two questions. Yep. One on ith value, and then in general. Ith value are you getting returned a collection there from an integer between 1 and 0? So like if you do the fifth value, is it just iterating until it is there a counter internally when you when
you use ith value, there is a counter internally.
Okay. So internally, what it's doing is it's like counting several times. And then once it hits, okay, gotcha. Okay, yep. That makes sense. And then my other question is for all values is just taking the next proposition and just executing until exhaustion, right? So like in this case here, okay, all right.
What is the actual return value if you don't wrap that let form into one value?
Oh, you can't. An integer between is a non-deterministic function. So watch this. An integer between 5 to 100. An integer between is a non-deterministic function. As such, it can only be called from a non-deterministic context. You have to be using one of these things. Body of a Screamer defun, for effects macro, all values macro, one value macro, print values macro, ith value macro, possibly macro, necessarily macro. It is actually illegal to try and call a non-deterministic function outside of a non-deterministic context because it doesn't actually have a collection it's returning. It's using trickery to completely avoid the overhead of returning a collection. It also, interestingly enough, is actually going through, and I can kind of show you this, sorta. I'm about to do something that you generally shouldn't do, kind of. Like, it's not, like, against the rules directly, but it's a little weird, which is I'm going to have a side effect inside my non-deterministic computation. You can definitely do this, and actually Screamer has very well-defined behavior around how side effects work. But it can be weird trying to understand the output. But what you'll notice there is, the numbers that get printed more than once. Let's see, we'll say it has to be, instead, it has to be at least 10. Oh, did I do that wrong? Oh, not. So you'll notice that it tries 5, prints it, hits that assertion, and then it actually unwinds back up to here. And then it tries 6, hits that assertion, and then it unwinds back up to here. And then it tries 7, prints it, hits the assertion, etc., until we hit 11, which passes that assertion, and then we hit the second print. So that's why 11 gets printed twice. And it's the only one that gets printed twice. And if I pick a much smaller range here, say, between 5 and 15, and we make our assertion be like, even px, we say all values, then you'll notice that the even ones get printed twice. Because there isn't actually, there is no collection that an integer between is returning. It's actually returning these values one at a time. Although somebody who actually understands the internals of Screamer would yell at me for saying that it's returning values because of the magic inside Screamer and how that actually works. But you can think of it as an integer between is returning these values to you, and it's giving them back to you, one at a time. And
I don't know if you can see this, but there's a question in the chat. Oh, Richie's asking.
I cannot right now. Actually, it is exactly continuations. Screamer is a CPS transformer internally, since you seem to have some idea of how that is and what that means. Yes, it's using something similar to continuations for the rewinding. And yes, the answer is it is actually doing a full CPS transformation, going all the way to continuation passing style, and then it's what's actually happening is anytime you have a non-deterministic continuation, it's just calling it multiple times. And, the value that's quote-unquote being returned is being called, the continuation is being called that value repeatedly. But for all of you who don't, deal with continuations or any of that nonsense yet, just ignore what I just said there. It's easy enough to think of it as returning a value, and that's sort of the whole point of how Screamer has set itself up. It's meant so that you can think of it like it's returning these values, and then it's rewinding. Only when you start getting into the really, low levels of the Screamer, API, that you start seeing things like the ability to actually control how that rewinding process works and what's actually going on there. So, anyway, so you have this sort of, forwards and backwards thing going on here, and then it eventually produces these values for you. And as you can see, only the even ones get printed twice. So that's an integer between, and there's actually quite a number of these non-deterministic functions just built into Screamer. There's a member of, there's quite a few of them, and actually if you go to the Screamer website, you'll find quite a bit of documentation on all of them, and we'll probably see a few of them later on when I get to the first longer example. But I have this function over here, some of you might have, oh yeah, a member of, that's another one. It selects a value non-deterministically from a list. I think it might also work for a vector, but I've not tested that myself. Some of the member thingies work with vectors as well as lists. I just only ever use them with lists. So ignore that for now. Anyway, so here we have a summed square between. So what we get here is we have, 2 bounds, and what it gets is, it pulls out an integer between those bounds, and then it computes, the square of each of those numbers and adds them together, and then produces this nice list for us. So we have, one value, one particular, summed square, between where the bounds on the input are, say, 0, 5, 0, 5, or 50, say, 5. It'll start with 0, and we can limit the lower bound on there. And, it's starting with the lower bound just because of an implementation detail of how an integer between works.
So, quick question. Sorry to interrupt here, but just a follow-up here, because is there like some sort of, at least I didn't see this in the Screamer documentation, but could you point to some documentation that could tell us like how to write our functions so that we know that they're going to be non-deterministic functions? Like, is there some sort of hints?
Yes. I'm sorry. I should have explained that. You will notice I'm in the Screamer user package.
Okay.
The Screamer user package shadows the defun symbol. So it's actually Screamer defun.
Okay, gotcha.
And that gives you a non-deterministic function. I was actually going to get into more detail on that once I started with the longer example, when I actually define a Screamer package. Define Screamer package is just a shorthand for def package with a few defaults, like automatically shadowing, importing defun from the Screamer package, so that your functions are non-deterministic.
Okay, thank you.
Sure. So we can of course do
Question in the chat.
Shadowing. So that's a question about how packages work. So shadowing refers to when there are multiple possibilities for which symbol could be being referred to by a particular name. And so, like, if you use two packages that both export a symbol with the same name, you have to decide which one that you want. Marking one of those symbols as the shadowing symbol means it basically takes priority, and you can only ever have one symbol of a particular name be a shadowing symbol of that name. And that's a property of your package instead of the packages you're importing from, and so that way you're resolving that conflict yourself. You can also, even for symbols that are internal to other packages, you can do what's called shadowing import them. And that basically, without even using that package, it basically just goes and grabs that symbol from that package and says, use this symbol overriding anything else you know about possible symbols by that name. This is the symbol that I want to come up when, I enter this name in this package. So that's shadowing. So we have ith value here, and so we can pull the third summed square between there using my funny thing here. And of course we can do, all values. And then I'm going to, have a little fun here, which some of you who are watching before we started streaming will, what am I doing? All values. Trouble with, is typing in a live demo. So, there are all the ones there. So we have, the two values in there, square and sum. And then, of course, we can do some fun things like, let, sq be that, and, insert that the, that the actual, summed square be even. This is basically just, a longer example of what I was showing earlier. But it gives you, some idea of how you can really start with a very general thing and refine down to, just the values for when you square and add that together, you get an even number. And actually, you don't even technically need to supply an upper bound on some of these. Like I think you have an integer above is one of them. Yeah. So you have that. Although you don't want to use all values if you have an unbounded non-deterministic computation. That just won't go well for you. But you can actually have non-deterministic computations that can produce a possibly arbitrary number of values, and then you can just grab them out one by one using ith value or such. Or you can use a macro called forEffects, which actually lets you have a much greater degree of control over pulling out the values one after another, and actually ith value and all values are implemented in terms of the forEffects macro. Which,
question though.
Yes.
Like, is there any way to make it lazy evaluated? If you wrap it around to say a sequence that's lazily evaluated, like using series, for example, that's an unbounded collection. You're only grabbing those values that have been pre-computed up to a certain point. So I'm just wondering at what point would it say, okay, this is a non-deterministic function. I'm not going to, at least for integers, I'm just asking. Like,
Screamer internally is basically as lazy as it can be already. It only does as much computation as it needs to produce the current value you're operating on.
Okay.
And so you could definitely write a non-deterministic screamer function that selects a value from a possibly unbounded collection from series, in principle.
Mm-hmm.
Although the interactions between those two libraries could get a little funky.
Gotcha.
Screamer is a code walker. Series is also a code walker. When you start mixing two code walkers together, code walkers, for those who don't know, are particularly intense macros in a sense. They actually process all the forms and subforms of some expression that you've given to them, and they do some, mucking about. They do full code transformation. And so mixing series and screamer could be a little funky. I've never tried it myself. And actually there's some oddities with doing iteration alongside screamer as well, which we'll get into later.
But, theoretically, right, because they are code walkers, right, as long as you generate an intermediate representation that is amicable to the way, like, series does things and vice versa, they could work together, right?
Yeah, there's nothing stopping them from working together, assuming both of them have perfect code walkers.
Okay.
However, the phrase perfect code walker is one that is often laughed at by the community.
Okay, gotcha. Understood.
And Screamer's code walker actually is limited in a few ways that are kind of annoying, and I wish the developer would finally get around to adding cases for.
Another question I have is related to, like, let's say that you make because I could totally see using this in like an inferencing engine, like if you're, and you're doing forward inferencing or even backwards inferencing. At that point, let's say that you have a hash table or a database that you're trying to leverage to hold your facts, sort of like if you're using Prolog. At that point, I guess my question is how would you define like your non-deterministic functions to like handle some of those, like, oh, does this fact exist? It doesn't in fact. Okay, let's go and rewind that. Is it already built into Screamer, or is that functionality I have to build myself?
There are APIs in Screamer for handling unwinding, for handling backtracking.
Gotcha.
So there are a few ways you can do that. One of them is called the trail. And what the trail does is basically you can have a function and you call, you say trail, and then that function, lambda print low, right? That won't do anything because we aren't in a non-deterministic context right now. But if, for example, I did that here, what you'll find is that every time we backtrack, that function will get called.
Ah, nice. Okay.
And so that's one way that you can handle that. And so that function isn't getting called on the feed forward, it's being called on the backtracking. But every time we backtrack over that section, every time we rewind to the choice that was being made in there, every time we're rewinding back to that, all of the trail functions that were established after that and before the next choice will get called.
And would the code walker start at read time, or does it generate?
It's just a macro.
Okay, it is just a macro. Okay.
I have a question. It seems like something like this would be useful to do, to create something like quick check, to backtrack to see what the minimal test would be for something mail or something. Would that be possible?
Yeah. Don't see why not. You could definitely do something like that, and actually, you could definitely leverage some of Screamer's other ways of controlling how backtracking happens. In order to really give you some nice information about that. Because like one of the other things is Screamer itself doesn't actually try and undo global side effects, because it basically can't in the general case. There's no way for it to. But what it does do is, if you have it says a lexically apparent setf or setq, you can actually have Screamer cache the old value that was assigned there, and then on backtracking it'll reassign that. It'll revert it back to the previous value.
Oh, nice.
And so that there's a form called local and a form called global, and setf and setq side effects that happen inside of a local will get undone, and ones that happen inside of a global won't. And so that way you can, if you like, here, let me actually, just for fun, I'm going to try and re-implement all values real fast. F macro my all values and body forms. Okay, so basically what all values does is it starts with a let, oh god, I need a Jensen. And I don't have Alexandria loaded, so Jensen foo. So we let, G be nil, we for effects, we run forms, and then I actually need to catch that. Grab another Jensen. This is why we have with Jensens, people. I'm pretty sure that's right. There's probably a bug in there somewhere. But that's basically, this is how all values is implemented. Let's see if I did that right. Let's find out. By all values. Probably not, but Ah!
Oh, boom! You got it.
It's backwards. I forgot to reverse it. Traverse. Okay, so basically what for effects does is it runs all of the values. It runs until exhaustion, right? But it doesn't actually collect anything together. And so the entire purpose of for effects is for side effects. It's so that you can run, side effects. And basically what's going on there is I'm running whatever my non-deterministic computation is right there. I'm catching its return value, and I'm storing it in a list. But because I'm wrapped in this global here, I know for certain that even if that push expands directly into a setf, which it might or it might not in principle, even if that push expands directly to a setf, which Screamer considers as being a lexically apparent setf, even in that case, since it's marked global, it won't undo that assignment. And so that way, that assignment to that push onto this variable up here, survives all of my non-deterministic, going to exhaustion of all the possible ways of running this bit here. And that way, when we get to the end of it, we have our list, we reverse it, and we return it. So, you can actually very carefully control how the side effects happen in Screamer. It's a pretty flexible little tool.
Okay, cool.
That's really cool.
Yep. So, how do you guys feel about solving a puzzle?
Let's do it.
Okay, so let me just make another little scratch file here. I'm going to be basically recreating some code that's on the Screamer website, which is, for those that don't know, since I'm pulling it up on my tablet right now to make sure I have my nice reference, nicodemus.github.io. I'll post a link to that
Yeah, if you
chat.
go ahead and post the link, I'll post it on the YouTube description too for future reference.
Nicodemus.github.io, and yes, I'm being one of those terrible people that actually types out all of their URLs.
That's not necessarily a bad thing.
Yeah, so this is the Screamer homepage, and we're first going to go through, because I haven't even told you all the cool stuff in Screamer yet. I've just told you about the backtracking and the non-determinism bits. We're going to be going through this here, Einstein's riddle, which is, it's one of those fun little logic puzzles. You have 5 houses, and the Brit lives in the red house, and the Swede keeps dogs as pets, and such, and you have to find out who owns the fish. This is sort of the perfect problem for something like Screamer, because you basically just set up all the possibilities, and you tell it, well, it can't be that, and it can't be that, and it can't be that, and give me an answer. And it ends up being, really, really quite satisfying at the end.
So this brings up another related question to Screamer and its relationship to how Prolog is actually generally used.
Yeah.
So could you give a
Actually, if we get to the very end of this and we still have time, I can show you how in 10 lines of code to implement a really, really stupid sort of Prolog-esque language.
Excellent.
It's really slow. It is unbearably slow. I have tried working on a little compiler for it that actually makes it faster. It's not going well because of one of the little limitations in Screamer and me not wanting to re-implement pattern matching from scratch.
All right, understood. But I'm just kind of curious right now.
The version is 10 lines long and does work. It's just stupid slow. So I can show you guys that later if you once we're through a little bit more of this.
All right.
So, where was I? Yes.
There's a question in the chat before you get started there.
Oh, yep. Okay. What is Prolog used for? You will have to ask the people that use Prolog. Logic programming, a lot of the same sort of stuff that I'm showing you guys to be used with Screamer. It's designed to be used that way, sort of, from first principles. It was always meant to be used, as a non-deterministic programming language.
I can answer this a little bit more generally,
okay.
If I could take a stab at it. Basically, Prolog, from my experience, has been used for, honestly, a replacement for SQL. Like if you're using database query languages. In fact, some of the earlier query languages that essentially compiled from SQL ended up going into a Prolog dialect called Datalog that allowed you to write recursive queries. So if you're doing database sort of manipulation, Prolog is commonly used there. I used it actually in I know at least 2 commercial database projects where Prolog is one of the query languages to actually go and query the database. So one of them being Allegro Graph by Franz, the guys who make Allegro Common Lisp. So.
Yeah, actually, Prolog is really nice for that sort of thing.
Right.
So I'm just going to define a quick little package here, so I'm not mucking up anything I've put in Screamer user or any other, package. I'm using define Screamer package here, but that is literally just def package, and then it shadowing imports define multiple value bind and wire NP. I don't actually know why it snags multiple value bind and wire NP. You'll have to ask the Screamer dev. I don't think he documents that anywhere, but it does. I suspect the multiple value bind thing is because of some extra bit of weirdness in the way he does the transformation, but I have no explanation for why or NP. Regardless, it hasn't actually changed any of the behavior in ways that have affected me ever. So, I don't think it's an issue or anything. But this is basically all it is. So we'll, define this nice little package here. And so let me go ahead and grab this nice little comment here so we all have it.
Just a side note, when you're done with the setting this up, could you do me a favor? I'll send you the AFP GitHub repo URL and you can post it on there.
I mean, I would I would do that.
Okay, sweet. Okay.
The reason why I don't think it'll be particularly useful is basically because I am, for the most part, just going to be recreating all of this code here.
Okay. One additional question.
If we do the Prolog stuff, I will be perfectly happy to provide you guys with that code, though.
Excellent. All right. The other question I had is, did I see yes or no being overridden in that macro expansion?
Yes.
Okay.
Yes. Yeah.
Yeah.
Wire and P. I was saying something about that.
Okay. Gotcha. All right.
Yeah, I have no clue. I really do not know why that's shadowing imported. I could not explain it, but it is. Anyway, so let me do that, and let me in package Einstein and sync my REPL. I define the package and I sync my REPL. There it goes. Okay, that was weird. So we have some fun here. So the first thing that they do in that Screamer bit of example code is they define a couple little utility functions, which I will explain. First one is fact, which takes a bool and just does unless bool fail. This is basically assert, but lighter weight. Assert is actually a much more complicated little tool that involves Screamer's logic variables, which we will get to later.
Is assert a macro?
Yes, assert is a macro and a very complicated one.
Okay, gotcha.
Because it has to do a lot of processing to optimize uses of Screamer's logic variables and such. Whereas if you're just using it to assert a Boolean, it's basically just going to do this, but a little slower. And so, we also have not, which is, the other one is, when bool fail.
What does it actually mean for the exclamation point?
It really is just that it might fail. Screamer uses an exclamation point for operations that...
it's just denoting a non-deterministic thing.
Actually, those functions are deterministic. They either return or they fail.
So I do have a question there, because this seems to follow scheme notation.
Yeah.
So this is essentially scheme. It's saying that it's not mutable. It's not mutating the predicate. It's just essentially...
No.
Okay.
I had asked that earlier.
Oh, dang it. Okay, I didn't sorry.
It was before the stream, so you're fine. No, so yes, that looks very much like scheme notation. It is not. That has nothing to do with mutability. It's really just that the body of this function can call fail.
Okay.
And fail triggers backtracking, which means that you kind of want to know what things might call fail.
Okay.
Because you want to know what things are causing backtracking.
Gotcha.
Well,
it's the same thing that like in the only reason I bring it up is Scheme used it for immutability, and I just wanted to make sure it's not the same thing. All right.
Nope, it is not.
All right.
I wish he hadn't used the exclamation point there, but that is the style used throughout the Screamer library for denoting that stuff. So I figure it's better just to get used to it.
All right.
Yeah, I know.
At least it's not like Rust.
Yeah.
Exclamation point to denote macros.
Oh, I hate languages that make macros like syntactically different.
There's no reason.
Like, anyway, and the last one that they do is this and, which is a little odd until you look at it a little closer. And fact 1, fact 2, fact 1, fact 2. And not fact 1, not fact 2, or fail. So basically what this does is it's requiring that, it's basically asserting that these two Boolean values are if and only if is what that is. It's,
it's absolutely
fact 1 is true, if and only if fact 2 is true. They have that to both be true or both be false.
Right.
Otherwise we backtrack. Next we're gonna define a little, little struct to store our house. And, it's gonna have a color and an owner and a pet and a drink. I wish I could type today. And red, and a position. One moment, please. Sorry about that. Back now. People came home and I wanted to make sure they didn't bother us further. Is my mic still in a good position?
Yeah, you're fine.
Awesome. So we're going to define, this struct here, and it's going to store all the information about one of our houses. And then we need to define a couple of non-deterministic functions for producing the possible values we might stick in one of those houses. So first we're going to, define, a color, for example. And, it's going to, first, a member of list, red, green, white, yellow, blue. So we could just do this, right? However, what would be nice is if we could firstly prevent any value from being produced that conflicts with another house right off the bat. So the first thing we're going to do is we're going to make this, function here. And this does work. We can go ahead and test this, all values, a color, or all our colors. First thing we're going to do is we're going to make sure that if we give, some other houses, this function here doesn't produce a color that's already one of those houses. So we're going to say, let C be, that. And what we're going to do is we're going to say, cannot allow this this color here to be a member of our list. And this is, one of those cases we're going to start pulling out, some of the extra key arguments of member here. And in this case, we're going to use, house color. And, pretty sure the default test is fine for that one. And, once we get past that requirement, what have I done wrong?
List of houses.
Thank you. There we are. So now we can do that with, nil. And this is all fine. Or we can, make a house. List, make house. Oh. And we're going to give it a color of red. And now it did not produce red as one of the possible colors.
Couldn't you have made, in that case, the defund take houses as optional?
Yes, I could have.
Okay. I just wanted to make sure that that's okay. That's good.
Yep. Okay. Nothing's stopping you from doing that. Okay. It just doesn't do that in the Screamer code. So
is that list of colors actually being modified? Is that why you didn't use a literal there, or?
Yeah, that's a good point.
Oh, this one?
Yeah.
No, I could have just done this.
Okay.
That would have been safe.
Okay.
It is not modifying the literal list there at all.
Whenever I see list written out explicitly like that, I just automatically think that it's being modified somewhere.
Nope.
Right.
Nope. That is in fact a literal list, as is the one over here. This could also be a list literal. Actually, Screamer is very good for immutable stuff. Screamer is pretty good for pairing with an immutable data structures library like fset, which I have very recently started toying around with.
I as well, actually. It looks fairly complete.
Yep. But yeah, so because Screamer pretty much never modifies anything in place unless you modify something. All the side effects are yours for the most part. In fact, I'm pretty sure in all cases, like Screamer, until we get to logic variables, but all those modifications are internal to Screamer's own API, and so you're not supposed to really see them anyway. Screamer never modifies a user passed in object in place. So we have this a color function here, and it's already gotten a little complicated. And it would be nice if we could factor out some of the duplication that we're about to experience when we pull out the other 4 possible options. Screamer's code here does something that is actually a little unconventional in my experience, but is kind of neat to know about, that you can do this when you have a lot of repetitive stuff to define. It actually defines a local macro for defining one of these little functions here. And then it saves on a lot of code duplication that way. And so I'm going to sort of walk us through getting from here to there. So we already have our nice little function here that almost gets us what we need. And we're going to go ahead and turn that into the Screamer code that defines all 5 of them at once. Sure, my tablet doesn't auto-lock. I really ought to toggle that somewhere. So here we are. So firstly, we macrolet, and Screamer calls this def. We're going to give it the slot that we're operating on, and the name of the function we want to define, and the options that we want it to non-deterministically produce. And here is our pattern that we're creating. Screamer uses a regular CL assertion, 5 length options. Prevent us from making a mistake of, forgetting one of them. And we just define this here. So we say, this becomes name. And Screamer actually calls this not houses, but others. Go ahead and correct that so we actually have parity with the Screamer code. Calls it this. Still. Oh, Screamer actually uses the lower level either here, which is basically either just takes the values as a rest arg and then selects one of them instead of taking an explicit list object. But otherwise, it functions the exact same as a member of. It's just you have to pass in the values literally. So, it's one of those. But it's not one of these. It is, I'm going to actually save that because we'll use it later. It is one of the options. So this is one of the options. And we want to, now we need to, Screamer does something that's a little weird here, which is it actually interns a symbol. You may find weird, I find weird, but that's the code. Intern, format, nil, house, tilde A.
Interesting.
Yep. So basically, the reason for that is def struct here has created, house-color is the accessor for getting to the color slot.
No, right? I understand that. I just didn't know that you can actually. I guess it makes sense because comma is actually evaluating this intern beforehand.
Yep.
That's interesting that he would do that way.
And actually, he explicitly passes EQ as the test here.
Okay.
Probably is like I'm betting the default test is EQL, and we aren't comparing numbers or characters ever. So in principle, it's slightly faster. How
is that interning there that you did different than just writing it out?
So what I could do,
like you had
the way that I will show you, because the way he uses this is this. You see now?
Oh.
Yeah.
Okay.
We could avoid the intern by saying this. And just saying...
But you could have just set up
that would avoid the intern.
Right.
By explicitly saying house color instead of just color. But he didn't want to say house repeatedly, apparently. And assuming it's a he, I don't actually know. Apologize for people who are sensitive to that. My own biases get me sometimes. But anyway, so we now have this, nice little macro here, which generates one of these non-deterministic functions. And you saw how I, went from that skeleton to, this little local definer here. And now we can just say, def owner and owner. The owners are the Brit, the Swede, the Dane, the Norwegian. Almost never spell Norwegian the first time. It's probably going to kill me.
Now,
I'm tired of copying this by hand.
Interesting. I was just kind of curious if there was a way to actually grab the slot values from house and just do a for loop through that and say, hey, by the way, these are... But I guess since you're specifying a collection for each of those, it wouldn't make any sense, really.
Yeah.
Okay.
Oh no, what have I done? Oh, I was there when I pasted it. Okay. Owner, then pet. Okay. This is what I get for trying to rush. Bird, cat.
You have plenty of time, don't worry.
Okay, and that defines all of our little functions at once. So now we have, a color. We also have a pet. So we can say, we've already got a house where the pet is the dog. Get us all the other pets. Bird, cat, horse, fish. So that's, all of those. So next we want to define our house. Define a house. What does a house look like? It is going to take its position on the street, which is going to be a number between 0 and 4, because we can provide that information to it, basically. And this will shorten our backtracking. And actually, a lot of sort of the way that this code is written is in a way that limits the amount of backtracking that you have to do any time that you fail. We could write this in a really inefficient way by, generating all of the things and then asserting all of the conditions. You'll see in a moment what I mean. But that causes us to backtrack over the entire search space every time we see a failure, which is really slow. And so instead, we're going to, be a little more clever. So as I said, we could do this is we could just say, let the owner be, an owner. We could, and passing in the, we could let the color be color, passing in the others. We could, let the, pet be a pet. You get the idea. Thing is, if we do it this way, and we could definitely do it this way, it will be really slow. In the drink is a drink. Others. And the... I cannot spell cigarette.
So would this not... So you're saying that this will sequentially execute to grab each of these before running through whatever rules that you're going to specify in the let form?
Yep.
Okay.
Yep.
That's kind of slow.
Yeah, you see the problem, right?
Yeah.
It picks all the values, and then it runs through each of the constraints.
Yeah.
Right? And anytime it hits on a failure, it backtracks all the way up into here somewhere, picks another one of those, and then has to redo the ones below it. Right? It has to redo figuring out the ones below it. So actually what we want to do is we want to try and limit the amount of backtracking we have to do at any one moment. Right? And there's really no clean way of writing this code that doesn't involve a lot of nesting until we pull out Prolog later.
I hate to say this, but this is another use case for this library, which is you could use this theoretically to write an LL star grammar with multiple backtracking phases, right?
Yes,
like
you could. Yeah, it actually probably would look nice too.
So C++, we finally figured out a framework to actually write C++ parsers. It only took we're using Prolog to actually go and write a C++ parser.
let me make sure we have our rules over on the side here. So the first constraint that we're doing is, when the Brit is the owner, the house is red. That's, this rule right here. So we've just picked the owner and the color, and, so we're asserting our first rule. For the next rule, we need to know what the pet is. So, let, the pet be bad. And we'll assert that. So, when the owner is the Swede, the pet is dogs. It's a dog or dogs. It's a dog. Right. And so we basically just go through all the rules one after another. We can only talk about the rules that involve one house for this bit here, because we don't have any of the other houses. I mean, technically we have them in this others list here, but we don't necessarily have all of them. We just have the ones that have already been selected are going to be passed back in, which you'll see later. Actually, I might as well go ahead and show you guys what a street looks like, and it's simple enough that I'm just tired of typing, and I'm just going to copy it. Here's a street, right? So basically we just pick each house. We give we pick the 0th house, and we pick the first house, and we give the 0th house to it. We pick the second house, and we give it the first 2 houses, and so on and so forth. And that way, this house, here knows that it can't share properties with any of the 3 houses above it, right? But it's not discovering that after it's already selected something, and it has to, do the backtracking search again to find another possible value.
Interesting.
Yep. So is that sort of making sense so far?
It's making a little sense.
Yeah. It's weird getting used to Screamer, I must admit.
So in this code that you're adjusting here, that you're refactoring, there's no other way than writing nested platforms to actually.
Not any cleaner, unfortunately.
Okay, so the API doesn't specify some way to write. I guess the only way to describe it is parallel backtracking rules. Like you're deciding to go. I want to search, in different paths because I don't necessarily they're independent of each other almost, right?
Like, yeah, it does not specify that. No, okay, unfortunately.
Gotcha.
When we get to the Prolog example, all the nesting goes away because Prolog is kind of cool like that.
Right.
It kills all the nesting, kills it dead, and so if and when we get to the Prolog bit, we'll see all of that. I'm going to sort of start moving a little faster at this point.
Go ahead.
Because I have a second example that's similar to this but uses the logic variables. And I would like to sort of move quickly through this so we can then move quickly through that, and then I can show you the Prolog stuff without boring everyone to tears. So we have, Dane drinks tea, so Dane, EQ, tea, drink. Right, and so you sort of get the idea at this point. We're just going to go through all of these. So we basically just have all of these fun rules to write. Fun rules, yes. And basically at the end of it, we make a house. Ta-da! Just gonna copy all of that code there, as I'm wanting to get through this a little faster. And so that's that. I've not been typing the comments, and I'm not going to start typing the comments, so for consistency's sake, I'm removing them. But basically, we have really, in order, all of the rules that only depend on one house, right? And so we don't have things like, Rule 10 here, which is the person who smokes Marlboro lives next to the one who keeps cats. Right? We don't have rules like that because that involves knowing the positions of 2 houses. And so we only have, the one house rules here. Why does it not like that? Oh. There. Help if I, knew how to write Lisp. So here we can, get a house out. This is just a house in position 0, right? This is a valid possible house for position 0, and you'll notice that, like our rules say, the house in position 0 has to be Norwegian, and so it's Norwegian. And if we ask for all of the values, all of the possible houses that could go in position 0, you'll find that they are in fact all owned by the Norwegian. Every single last one of them. Because, any house that was in position 0 and wasn't owned by the Norwegian was, knocked off by this little line here. And, we can do the same thing. I'm not going to do all values for that, but we can do the same thing for any of the other houses in any of the other positions. And actually, now that we have all of this, we can actually ask for a street. We're already there. One value. What is a street? What does a street look like? What am I doing? Did I never actually compile that? I probably never compiled that. Yep. So this is a possible valid street using only the information local to individual houses and requiring that no two houses can, share the same thing in any of the, slots. So this is a valid street. Let's see. Length, all values, a street. There are a lot of possible streets. I forgot that there were that many streets. 2 years ago, that would have been perfect. But anyway, so basically, we have this, way of generating potential streets that doesn't consider the relative positions of the houses. And now we need to do the final, filtering out of all of the potential streets that have invalid house positions. And so what we're going to do is we're going to define another little helper macro. F macro house. And this is a house that has a particular key and a particular value. This basically, it searches our list of houses for the one that has a particular key in a particular spot. A particular, value in a particular slot, rather. And it uses that intern thing again, so apologies for that, but that's the code we have. And this is an anaphoric macro, for those of you who know what that is. It assumes a houses variable around it. It's anaphoric sort of in the other way. It isn't generating a binding. It isn't generating a binding. It is assuming the presence of one. We could make that a little cleverer by passing in houses, as one of the arguments. But this is a very, very specific use case macro, and the person who wrote it felt that it would be better just to have a little fun today. And so we have our test, and which is Q. I think it actually does this with those like that. So this, those of you who don't know, member is actually defined to return the sublist of a list which starts with the thing that satisfied the property you were looking for. And so member is actually closer to find than it is to just searching for the presence of something in a list. But because lists are truthy, it serves the purpose as a bool as well. We're not going to backtrack if we don't find it, because it is actually a proper problem in our code if we don't find a house that has this particular configuration. Because once we hit the point where we're using this macro, we're going to have 5 houses, and those 5 houses will have unique values in each of the 5, possibilities for things. And so every single possible value should show up in one of the houses, right? And so if we don't find one, we have a real problem. We might as well want to know about that. And then finally we have, he calls it riddle, he or she, whoever. They call it riddle. it gets, the houses, gets a street, then starts, inserting things. So, let's say, I'll explain this in a moment.
And, you can just copy paste the code and make it easier for you to do that.
Yep.
So,
I want to explain the first one, though.
Okay.
After typing it.
Well, I was just wondering if it is just a lot of code or not, if that made your life easier.
It's a little bit of code. It's not a ton of code.
Yeah.
It's a little bit of code. So basically, this is that rule that the greenhouse is on the left of the White House, right? What that really means is that it's, positioned one less than the position of the White House, and so we do house color white, which by our nice little macro here, we'll locate the house whose color is white. We ask for its position. We subtract 1 from that. We pull out the greenhouse.
Don't you mean 1 minus?
Yeah, it's 1 minus. I don't think it's -1.
Yep.
Yeah.
You're right. It is, in fact, 1 minus. I never use that. I always write it as, minus thingy 1 because I actually really dislike the 1 minus function. It just looks weird to me.
The 1 minus 1 plus.
1 plus I'm fine with because that actually reads like it makes sense. This is not 1 minus the thing. It's the thing minus 1.
Right.
And that I've never liked that. Like, I understand, it fits with the style of 1 plus, but were ink and deck really that hard? Could you really not just
Right.
waste another character there? It'd be clearer for all of us.
I bet you it's because of an existing Lisp that had 1
Yeah,
minus.
yeah, probably. I'm almost certain. But yeah, so you guys see what this is doing, though, right?
Right.
So we're basically we are asserting that the position of the greenhouse is 1 left of the position of the White House.
So, like, at this point, you could easily insert this into like a list of facts, right? You could just go one step further and start saying, okay, I'm going to start inserting. I'm going to have a list of facts that has all this to make sure that, so that way you could start querying against them and have a simple fact base because that's just one smaller step towards essentially what you want. What I was asking earlier, which is Prolog, right? I mean, you could keep going that way. So
yeah,
interesting.
So here's the rest of that code.
Yeah. Nice.
It's a lot of code, but basically, we then want the house's pet is the fish, because that's the answer to our question here: who owns the fish? And so we're Rule 10, when he smokes Marlboro lives next to the person who keeps cats. So, we take the absolute value of the distance between them, and we see that has to be 1. Person who keeps horses lives next to the one who smokes funhill. Same thing for these. I don't really know.
I'm trying to understand that. Rule 15.
Person who smokes Marlboro has a neighbor who drinks water. I don't know why it chose to write it like that, to be honest.
Oh, I see. He's basically saying, okay, I don't care if they're the right of me or the left of me. I have a neighbor who drinks water.
Yeah.
So.
Yeah. But, I mean, the thing is, this accomplishes that just as easily.
The absolute value. Oh, right.
Yeah.
Well,
I don't know why.
you'll grab one of them. It may not be grabbing all of them, possibly. I don't know. That's
Anyway,
yeah.
we can now find one possible value which satisfies our riddle. That tells us that the owner of the fish is the German. We can also, for those of you who want to see the full solution, just ask for the value of the houses. And there are all the houses. Positions. And we can even, go up here and verify a couple of our properties, like, the greenhouse is on the left of the White House, as it is, and, the Dane drinks tea, and the person who smokes Marlboro has a neighbor that, drinks water.
Right.
Yep, there they are.
Cool.
There it is. So that's solving this using just straight backtracking, forward propagation and backtracking, and all of that fun stuff. So the next thing that we're sort of going to get into is this idea of what Screamer calls a logic variable. Logic variables are interesting. Basically, a logic variable is a box, in short. It's a box, it contains a value. However, it also contains a bunch of rules about what potential things are valid to be stuck in that box. If it finds that you try and stick something in the box that doesn't satisfy all those rules, it fails, which triggers backtracking. And so,
Elijah, quick question.
Yeah.
Is there a way to get this to easily print out like the steps it's doing when it's backtracking? So when you're printing out the solution, is there a way to be like, okay, print out everything that's happening up until the solution?
There isn't a general Screamer debugging thing that I know of. There might be. I wouldn't be surprised if there was one somewhere deep in there. I don't know of one, but you can always, add debugging stuff. I mean, you can just print stuff wherever you like. Print horses.
Actually, you could write it because of the way Screamer's code works when it's backtracking. I think it's all it is. It's really you putting it in the right place. So when it backtracks, it prints out what the current state is, and it'll generate.
Yeah, I wasn't sure if maybe there was a alternative to the fal or something where it would do a fal print or something.
I mean, you can always define a fail that prints stuff out, but it doesn't have an internal thing that. Actually, there might be something in the Screamer API that will tell you every single time it fails. I wouldn't be surprised.
I'm looking at the Screamer documentation to see if there is one. That's actually an interesting question. If I find one, I'll just I'll let you know. Possibly necessarily. Keep my mouth shut.
Ignore me.
Yeah, sorry.
I'm definitely not examining the Screamer internals on stream.
There is something called. No, that's print values. That's different.
So there's the trail, of course, and there's when failing, both of which you can use to trigger something to print when a failure occurs. I don't know of a simple way that you can just make Screamer all of a sudden, fail. You could, because of the way fail is defined, which I have just discovered, you could actually rebind this dynamic variable here. It's probably an internal variable in the Screamer package because I cannot imagine why he would export that. Let's find out. It is internal. Yep. But in principle, you could do something like, diff parameter real fail. It's, Screamer. Patching is fun. At Q, Screamer fail to be a lambda, which prints out, failed, and then, uncalls real fail. And now every time we hit a failure, it'll tell us. It's a lot of times. And we can, fix that again by setting.
I don't think I've ever seen anybody use setq before.
Yeah, that's really wicked that you're using
Shush.
setq.
I don't think there's any really good purpose here.
There's never a good reason to use setq, but my muscle memory fails me sometimes.
Can we actually change that last rule there, the one that you said could be used using fact, and see if it produces the same result?
Oh, could be using the absolute value
The
subtraction.
left and the right, and get rid of all that, and just use the yeah.
Sure. Let's find out.
That's just kind of confusing to try to read.
I agree. So that's rule 15. The person who smokes Marlboro has a neighbor who drinks water. So I'm just gonna. So the thing is, we already know the position of the person who smokes Marlboro. So we just need the person who drinks water. And in principle, we should be able to do equals 1 abs minus difference between Marlboro and water. A little different because these ones have the house position explicit, although that one doesn't.
So that's interesting. Okay, that's really the nature of the algorithm that you're.
That ought to be the same.
Yeah, it is the same because everybody has a single drink. It's not they could drink more than one. Like,
let's see what is my hash v equal p compares structs, right?
Yeah, I think so.
It won't show me that. That's annoying. How far back is this? It's 2 values back, so that should be 53.
Instances of a struct, that should be EQ.
No, I need to know if their slot values are the same. Yep. Yeah, equal p compares struct values using equal p. It recursively compares the slots of a struct using equal p.
Okay.
It, however, compares strings case insensitively, which drives me bonkers.
Right.
But when you need to know if 2 structs of numbers and keywords are the same, people do that for you. It will not compare class objects, though. Nothing compares class objects directly, unless you pull out the meta object protocol. Or write your own comparison function. But anyway, so that's pretty much all there is to this one. And then we start getting into fun stuff like logic variables. So if everybody is sort of satisfied with what we have here, let's start getting into logic variables and how they can be fun.
Absolutely. Any questions so far from the rest of our audience? Feel free to throw it into the chat or into the live stream if you have questions. I think we're good to go.
Cool. So logic variables you actually get logic variables pretty much the same way that you get non-deterministic function values. Or perhaps I should say, almost all of the built-in non-deterministic functions have an equivalent, which produces a variable, which is constrained to only be allowed to take on the values that would otherwise have been returned by its corresponding non-deterministic function.
Yeah, sorry. It looks like we do have a question.
Yep.
In the chat. If you can open up the chat there, I think he wrote.
1 second, I'm clearing my REPL.
All right.
Oh, what were y'all saying about setQ? I like how your Emacs looks. Yeah, it's Spacemax. The mode line theme here. I think I actually have it open over here because I was doing some hot patching to my config earlier. The mode line theme is .spacemax mode line theme is all the icons separate or none. You want to read the documentation on the all the icons theme. It will tell you the thingy you need to run. I think it's font. All the icons install fonts. That'll get you all the fonts that give you these fancy things down here and such. Yeah, short little side thingy there. But yeah, that's my. Oh wow, that question was asked a while ago, and I completely missed it. Sorry about that.
No, I think Michael answered it actually. He said.
Oh, so you did. Thanks.
The latest one is about setQ and what we're talking about.
Yeah, we just don't use setQ ever. Do as we say, not as we do. There's never a reason to use setQ.
For all modification functions, I think the recommended way is to use setf. Not
setf is always better than setQ. Yeah. setQ is hacked together so that it works even in the presence of all the nonsense that it needs to handle, and it even expands to setf in some cases.
So, bottom line, folks, always use setf if you're using a set function.
There's no reason to use setQ. It's basically just a subset of the functionality of setf. And it's the same number of characters, and when it's just a variable anyway,
yeah, why use both when you can use one?
Yeah, and if you have a symbol macrolet, right, and you try and setQ that, it will work, but it'll work by expanding to setf and letting setf handle the symbol macrolet. And so it literally is just sort of a backwards compatibility thing. setQ only exists to support, previous stuff. Anyway, so logic variables, right? So we have, let me create a little logic variable here. Logic variables, most of the logic variable API is actually deterministic. It is, for the most part, it is deterministic functions. There are, bits of non-determinism in it, but for the most part, the logic variable API is actually deterministic. So you can do things like an integer between v, and now it produces a variable instead of being a non-deterministic function. We'll say that. Now if we look at v, we'll notice that it is this funky, thing. It is, it named this variable 1. It's actually a variable name. I could have actually passed in, a name for it, like that. Now we have it named there. Its type is integer. Its range is between 5 and 10, and it actually has what's called an enumerated domain, which means it has a nice list of the possible things that variable is allowed to take on. So this is a logic variable. You can actually just do make very... Help if I could type.
Interesting.
You can make a variable. That variable has, no constraints assigned to it. We can then do fun things, and this is where assert comes back in. Assert member v, that variable up there. I'm just going to snag that out of my history and say that it has to be a member of the sequence 1, 2, 3, 4, 5. And now, if we look at that variable again, that one there, And that suddenly it's gained an enumerated domain and its type is integer and such and such.
I just want to mention that this sharp sign V thing is not part of Screamer. It's actually part of Sly.
Yes.
We haven't touched upon that when I talked about Sly, so I just want to throw that out
there. Yeah, that's a Sly feature. It's a thing that happens when you're in the REPL. It's a little extra reader macro they added for accessing the previously returned values. For those of you that don't use Sly or use Sly and aren't aware of that, it is really convenient when you forgot to assign something to a variable, as I am ought to do. So, we have this object here, and if we then, assert that it really needs to be, our variable up there, what was that we were saying? 4? Yeah, 4. It really needs to be 20. We fail. Because there's no possible way to assign that variable to 20 and satisfy all the constraints on it. So this is basically really all there is to constraint logic variables. It's a little more flexible than that. Actually, there are quite a variety of different constraints that Screamer understands natively, and actually you can even attach arbitrary constraints to logic variables, although there's no way to do that in the public API that I know of. But in principle, you could actually basically constrain these variables to each other any way that you like. And then, in fact, you can do fun things like, let's, make 2 variables. We'll call them, x and let's start it off with a range. 5 and 10. We'll name it x. Right, and we'll do the same thing for some y variable. X is now y. If we look at x and we look at y, we have these 2 nice variables. One fun thing that we can do is we can say, hey, yes.
I have a question. So what's that third parameter again for this V? I'm still confused by this.
It's optional. It's a name. It's just an arbitrary object that gets carried around with the variable and printed out whenever that variable gets printed out, so that you know which variable is which.
Okay, all right.
It literally can be anything. You can stick a string there. You can stick a number there. By default, Screamer has a little, variable duplication of terms. It has an internal variable, not a logic variable, a regular variable. It's just a counter. And if you don't supply a name, it just picks the next integer up, and then it increments that, so that you just get these numbers, and eventually you get square brackets 580, and you wonder why you made that many variables. And it tells you absolutely nothing because you haven't been assigning names to your variables.
Okay. No, I mean, I understand the use. I can see the use for it from looking at the REPL. I just was wondering if that's just an arbitrary label, or if it's a symbol.
Literally anything.
Okay, so it can be anything that you.
Yep.
Okay.
Any object. Any object you like.
All right.
And everything's an object, so. One fun thing that we can do is we can say that equals v. That the sum of these 2 less than v, the sum plus v. You're starting to see where this is going, right? I have all these, funky extra functions that are like all the regular functions, but they operate on variables. Let's say that their sum has to be less than 12. Let's just assert that, right? And now we can say, let's say I'm going to create a non-deterministic context here. This doesn't actually do anything but give me, but undo any of the variable stuff that I do inside this little block of code. The one value, I'm only using deterministic functions inside this one value. But the nice thing is, when it unwinds all the way out, it ought to undo any constraints that I assign to those variables, so I don't have to recreate them later, basically. Because because there's no way to reverse constraints on variables after the fact except through backtracking.
So within this, you're essentially creating a specific context to temporarily shadow the previous constraints and allow you to. Okay, all right.
Well, to further constrain, because I can't undo a constraint that's already been applied. I can't relax the constraints on a variable. There's no way to do that in
would
the
that
API.
follow like a horn clause then? Like it's anded? Like they
Yeah.
Okay. Right.
So, I could, for example, assert, that x needs to be, let's say, 8, right? And then I could, assert that, y needs to be 9. These are both values in their, valid range, but we will find
Nothing.
we found nothing.
You found nothing.
That's interesting. That ought to have erred. I don't know why I didn't.
You're still within the valid ranges there. So
Right, but their sum is greater than 12, isn't it?
Oh, right. Okay. Yeah. X and Y are 8 and 9 are sum is greater than 12.
That should have. Oh. I always forget this. Wrap, slurp, prog-n. One value takes a form, not a prog-n, and it still doesn't. What have I done to those variables? I've probably screwed those variables up now. Nope, they're fine.
Huh.
I'm used to that being a problem. Oh well. Yeah, that is weird. It's funny, I thought I knew this library. Let's see if we can see.
There's a question in the chat about what the first equals v is for in that code. So like
this one.
it.
Oh yeah. That constraint did nothing. Yeah, thanks for that. that constraint did absolutely nothing. Let's actually make that useful and remove that bit there. There we go. Now it ought to fail. Fail. There we are. There we are.
Thank you,
Screamer
Mr.
is
Primus.
fine. That was flawed all along. Yeah.
So what you're saying is Screamer makes you scream?
Yes, occasionally. Occasionally it does.
Yeah.
Occasionally it drives me crazy. But yeah, so we have this thing here, and we can of course pick values that don't violate the constraints. Like, I said less than 12. 3. It's not undoing the constraint I put on it. What?
What is that? That doesn't look right.
Yeah, that doesn't look right at all. What have you done, Screamer? I feel like Screamer is drunk and I've, completely confused it.
You may have. Start over again. Try to reassert.
Yep, let me recreate those variables and reassert them, because I've probably screwed something up along the way.
Yeah.
Let's take a look at our variables after that assertion.
Ooh.
Oh, interesting. It is decided that the only things that those variables can possibly be are 5 and 6.
That's cool. That means it's updating the logical constraints as you are adding your constraints to the domain. The logic variables ranges are being updated on the fly. That's actually.
Oh right, I forgot I set the minimum to 5, so it can't possibly be 3.
Yeah.
5 and 6. That one succeeds.
Yay.
Hooray. Okay, so, here's the interesting thing, though. Because not only can we do that, we can use this fun little operation called solution. And do this. List y. I will explain what this does in a moment. Static ordering linear force. 5. Ta-da! Figured out one of the possible values for that variable. Trying to format the code so it's readable. Not using the right keys. So basically, I added this assertion here, right? And then I give this function solution a list of other variables I wanted to try and find values for. And this right here, basically what this does is it tells solution, it's basically a way for you to give solution a heuristic about what order to go through the domains of each of the variables in, and which variables to, try and constrain further first, and a few other things.
What does linear force specifically do?
Linear force basically means it requires that the variable has this enumerated domain, right? And it basically goes through the values one by one.
Okay.
The other force function is divide and conquer force, which requires that you have upper-lower bounds on your range, or an enumerated domain, I think. And basically what it does is it first cuts the possible range of values in half, and then it tries another variable and subdivides that one, and it tries another one and subdivides that one, and it keeps going through the variables one after another, subdividing them until it hits something that works.
So that's a logarithmic. That's a logarithmic for force function versus a literal. I'm just wondering what the ordering was. Like, is that doing first to last, or is it in idle order?
So linear force just goes through first to last. Divide and conquer does the splitting.
Okay.
However, important point is those are non-deterministic. Solution is a non-deterministic function. It is it produces all of the possible solutions.
Gotcha.
So linear force is choosing one of the values, one after another in order, in the range, and non-deterministically deciding that should be the one that we assign to the variable, which means that if that fails, it will backtrack to that choice and it'll pick another one for that variable. Which is what allows it to find, possible configurations of multiple variables that are valid, even when the constraints between the variables aren't immediately apparent in the definition of the variable itself. Because you could have some really, really funky constraint that, Screamer isn't able to automatically figure out, reduces your, domain to be some nice small numbers there. I could have come up with a much more complicated constraint involving like squares or something like that, and it probably still would have figured out bounds that it could assign to those variables, because for integer math, Screamer is actually really clever. But then you can get funny things like, as we'll see in a bit, variables whose values are, like keywords. And when you have variables whose values are keywords, when you start constraining things, it gets a little less clever. And so you just have to it has to try stuff and see if your constraints force it to backtrack. But regardless, solution is a non-deterministic function, which means we can actually ask for all the possible ways that we could assign values to those variables. And you'll note that the answers are 5 and 6. Because, when we set that. However, if we were to constrain x to be 6, now it's only 5. Because if y became 6, that would be 12, and, 12 is not less than 12. So there's that. And so that's sort of the logic variable stuff. And actually, the logic variable stuff can get a bit more involved than that, but not by much. And the neat thing is that you can actually do basically that entire process we did before with the solution to the riddle using logic variables instead of backtracking. Well, you are still using backtracking, but you're limiting the backtracking to processing the constraints on the variables. And I don't think I'm going to copy that code one by one. I'm just going to go ahead and just grab all of it. And then I'm just going to walk us through that code, because we've already seen this once, and it's very similar. It'll be more important seeing the differences because of logic variables and actually walking through the code bit by bit.
So I have a question. Is solutions effectively doing reification then? The solution function that you just passed, is it actually going through and saying, okay, these logic variables following, is it actually trying to solve the constraint satisfaction problem? Okay. All right.
Yes. Solution is trying to come up with values for each of the variables you passed in the list.
So is there a way, I guess, then to use solution to query only one of those values, or is it only going to, like, could you ignore one of the logic variables, like when you're
You don't have to pass all of them in.
okay? So those are optional.
Solution is only trying to find exact values for the variables that you pass it.
Okay. So that's why that first argument is a list there.
Yeah, I'm pretty
Okay.
sure that if I only have one variable I wanted to solve, I don't even have to pass a list. I just do anyway because that's how I'm used to using solution. I'm used to having,
Okay.
A list to pass it.
Cool. All right. That makes sense. That
Technically
makes a bit more
speaking,
sense.
Yeah.
It makes much better now. Okay, thanks.
Technically speaking, the list doesn't even have to all be variables. Some of the things in that list could be values, which sounds weird at first. Basically, solution just ignores the things that aren't values. It turns out that that's really convenient when you start mucking about with some more complicated invocations of the variable system, where you start doing things like apply substitutions, which takes in a cons tree, not just a list, but an arbitrary structure of cons cells where the leaves are atoms, and it goes through that entire tree, and anytime it comes across a variable that has been constrained to have an exact value, it substitutes out the variable for its exact value, but any variables that haven't been constrained to have an exact value basically get left alone. And so you can give a list to that of things that are some variables and some not, and that apply substitutions will get rid of the variables that have values, and we can actually see that if we get rid of this bit here and we just say apply substitution list x y, we'll find right 5 there. And we get 5, and we get back our logic variable there. And actually, this logic variable is does not have those constraints on it, because we've completely exited that context, which is constraints were assigned. So, apply substitution, since it saw that this x here had a defined value, it replaced it. And actually, in this case, if we assign x to 6, that solves all of the constraints immediately. It actually immediately constrains y to be 5, because that's the only possible thing in its range. It still makes sense. And so then when we do the apply substitutions, it substitutes out both of them. And so when you're doing some apply substitution stuff and then some solution stuff, you'll often end up with lists that are partially variables and partially values. It's just convenient that solution will just ignore the things in the list that aren't values. A lot of parts of Screamer will basically just treat values as if they were variables that were already fully assigned, and just operate on them that way. Which is why, I could have, when we did that, when we did this thing up here, right, I could have put a variable over here as well, and we'd have this really complicated system of equations. Not that complicated.
But that wouldn't be a lot. That since that's a fixed value, that wouldn't be a logic variable, right? I mean, are you saying that you could?
That is not a logic variable, but I could put one there.
Okay.
Is my point. And actually, this right here, this plus v, is returning a logic variable.
So I have
That's
a question.
Part of,
could that last value there, that 12, essentially be a range too, like everything else, and then
Yeah.
Okay. All right. That's interesting. Okay.
Yeah. I could do that, and then I'm just gonna do the x to y thing again, because I don't want to scroll all the way up through my history again. And I could make a z even, y to z, and say that has to be between 5 and 20, or maybe let's say 10 and 15, right? And then I could say
Because by this time, actually, because of what we saw earlier, technically, x and y, when you add this z, will get updated ranges, right? So could you hit enter and do star x and see what it gives you?
Yeah. So it discovered that we cannot give x the value of 9.
Okay. Cool.
And we also have discovered that no possible configuration of x and y will produce a z that is 10.
Could you
This
put,
thing is this constraint is bidirectional, right? We've not only constrained this to
print
be
y?
less
I'm
than
sorry.
z,
Could you print y, please, so I can see what y is?
10 is x.
Interesting.
So this is a bidirectional constraint, right? We've not only constrained that x and y have to be less than z, but we've also constrained z has to be greater than x and y, right? And so, if we pick the smallest possible values of x and y and add them together, z has to be greater than that. And since, or rather the largest values of x and y and add them together,
Okay.
z has to be greater than that, right? And so, z can never be 10, in short.
Interesting. That's really cool.
No, the smallest values. What am I thinking? Yeah, right. Because if we assign x and y their smallest values, that gives us 10, right? And so z has to be greater than that, and so z's domain, goes up a little. But if we, assign x and y both, 10, or if we assign x 10 and y 5, right? That's 15, and that's greater than the, largest value of that's equal to the largest value of z, and so that means that it can't possibly be that it can't possibly get that big, right? And so even with the smallest possible value of y, right, x can't go over 9, because then there would be no assignment for z that would allow that system to work. So Screamer is doing all this fun little math for you. And, we could, of course, ask for solutions depending on constraining any of those 3 variables. So let's look over here at this new way of solving the problem. It is the zebra problem, which is very close to the Einstein problem, but slightly different because of a variety of reasons, I'm assuming. We create, this let integers between v, which gives us, a min, max, and a variables list and a body, and it basically just goes through each variable in the variables list and says, let that variable be an integer between min and max. Right? And so we use that, here to create, variables. The way that he does this basically is, the Englishman needs to be in one of the houses between 1 and 5. And so we're going to create a variable for the Englishman, which is the position of the Englishman, right? And the position of the Spaniard, and the position of the White House, and the position of the sculptor, and the position of the person who drinks water, right? And so each of these end up being variables between 1 and 5. There are plenty of other ways that you could do this. This is just one of them. So that way, this let integers between v there is creating all of these, variables, each are an integer between 1 and 5, basically. And then we have this all different v, which basically, and I've actually looked at the implementation of this right here, and it's actually this exact code, so I don't know why he bothers redefining it. He says it's functionally the same but faster, but it's actually the exact same code, so yeah. But basically, all it does is it asserts that all of the variables in this list have distinct values, right? And so that means that, if we have our list of nationality variables, if we assert that they're all different, that basically means that none of these can be in the same position because our variables are representing the position of that thing.
So, can I just ask a side question about this?
Sure, go ahead.
So, in all different v, how? And I'm asking because I didn't know that this was the case. How would apply? Why would apply be slower than what he did?
I don't know.
That doesn't make sense to me.
It doesn't, actually. And I've looked at the implementation of not equal v, and it takes a rest arg, and then it literally does this exact code. So I couldn't tell you, honestly.
I guess I'm going to have to compile this and just see what the
Yeah.
the assembly is. Yeah, that's the only way.
Yeah,
or-
I'm pretty sure on SBCL it would be exactly the same, but on some Lisps it might be different.
Okay, that's a good point. I didn't consider that. Okay, thanks.
Some Lisps might not optimize that apply quite as effectively. I can't imagine which Lisps might not, because that seems like an obvious optimization to me. But some Lisps might not optimize that apply such that it, is fast as passing the list as a single arg. That's the only explanation I have, honestly. Another possibility is that this example was written before the code behind that was actually updated to be exactly this. And so originally there was actually a really slow implementation inside of there, which has since been replaced to match this code.
Oh, I see that way too much documentation existing far after.
Yep, that's the other explanation that I have. I have two explanations, and those are them. Anyway, so, basically it does, the same thing. It, it asserts that these are all distinct values, right, which we did before by asserting that, it didn't show up in our list of houses. But in this case, we're just asserting constraints on the variables. We set these are kind of fun. I don't know why he decided to do the, neighbors this way, but basically, we have basically distances between houses, right? So we have distance 1 is between -1 and 1, and it isn't 0. There are better ways to have done that, but that's the way the code is here. For example, they could have done, distance 1, a member of the, list -1, 1. I'm fairly confident they would actually be exactly the same. And
You can make that a fixed list, right?
Hmm?
You can make that you don't need to specify it explicitly as a list, right? It could be just a quote. Yeah, okay. Just want to make sure. All right.
Yep. I just don't, just as a personal style thing, I almost never use quote in actual code. I almost always, if I use quote, I use it at the REPL.
Okay.
Just as a personal style thing, there's no real reason for it. I've just gotten out of the habit of, using literals like that, using mutable literals, because it feels weird to me, and it can cause undefined behavior. Like in all of these cases, it'll be fine because I know how Screamer works, but I don't trust all libraries to be that sane.
Duly noted.
I've read the code inside of Screamer, most of it anyway. I've understood parts of it, and I know that Screamer never modifies the value I pass it, so I know that would be safe. But still, just my habit is I almost never use quote to create a list. It's just a personal thing. But anyway, so then we have the the actual constraints. The Englishman is in the red house, so they have the same position. Japanese is a painter. The diplomat in the yellow house, and then we have this here, which is the Norwegian and the blue house are neighbors, right? So there you have the distance between them, and that equals this distance variable, which is just something between -1 and 1, right? I would probably have just inlined that variable right here. I would have just been like, a member of the, list -1, 1. Just done that. It's like, I'm fairly confident that would actually be equally efficient, if not more so. But that's how the code's written. So if you refer to it later, that's what you will see. And then basically we just go into solution here, and we pull out, we ask for the positions, we ask for it to solve all of these variables. And here we're actually giving a list of lists of variables here, because remember, each of those is itself a list of variables. It actually really bothers me that this guy capitalized all of those variables.
Yeah.
I think that stems from if you use
It's a Prolog thing.
Yeah, if you use Prolog, you're forced to actually do that.
Yeah. Logic variables in Prolog are capitalized, whereas the atoms are lowercased.
Right. And I think he just wanted to be consistent. I'm guessing.
Yep.
That's the only thing.
Yep.
Okay.
Only explanation I have. But yeah, so then we have that, right? And so we just pull out, we assign values to all the variables in all those lists. And then, we pull out the ones that we care about and we print out the solution. Did I not? Oh, because I didn't define that macro because I'm not going through the code in order. It would help if I went through the code in order. Or just loaded the entire file. That probably would have been smarter. Let me sync my REPL. And zebra problem. Yeah. Ta-da.
Wow. I mean, honestly, this is actually just really. I mean, this shows even logic programming in general. Like, it's just a matter of stating your facts, like declaring your problem by stating your facts correctly, and then whatever question you want, just go through and ask.
Yeah. Yeah. No, like Screamer is a logic programming framework. It calls itself a non-determinism system because the primary API, the stuff until you hit logic variables, is really more oriented for non-deterministic programming, but the variable system turns it into a full logic programming framework.
Cool.
Yep.
That is just very nice.
Yeah, isn't it neat? And so finally, if we have a little time, I will show you guys how to make a quick Prolog.
Go for it, man. I'm really looking forward to that one.
10-9 time.
Hey, question for folks. Are there any questions currently about what we discussed so far, like especially on logic variables?
Yeah.
Doesn't look like it. Hold on. Judd, do you see anything on the live stream? See if there are questions. Okay, go for it. What questions?
I'm on live stream. Why? What's up?
Are there any questions on the live stream?
What at 7 p.m. it was what's the first equals v.
Yeah, but that was that was the Hangouts.
We answered that.
Okay. We took care of that. Okay, cool. I think we're good.
Yeah, am I still watching the YouTube stream? I don't think I am.
Yeah,
I was having that up on my tablet, but I'm not on that anymore.
Yeah, I didn't see anybody on the YouTube stream. But I noticed somebody joining in like about 15 minutes ago when we were touching logic variables. So I thought I'd ask.
Yeah.
All right.
So here we are. Let me find another Screamer package. Oh, we've got an echo.
Okay, whoever's listening to the live stream, could you put yourself on mute, please?
Yeah.
All right, we're good. As soon as I heard mid-sentence, I was like, okay, the guy muted himself. So.
Yeah. Okay. So basically, this is a really, really stupid Prolog. Like, just absolutely dumb, but it'll get the job done. And it's only really Prolog-esque. It's not fully Prolog. But as I said, it'll get the job done.
Folks, when we cover PAIP, which I am planning on covering PAIP, we will be talking full Prolog there.
Let me just define some dummy macros so I can show you the code that I want. Known and head and body. Let's call it body. That'll do. And query and body. So basically, what I want to be able to do is say things like, and I'm sort of thinking now if I have a version of this code somewhere that is a bit more fully fleshed out that I can actually copy the example from. I don't think so. one that I can actually copy the example from that won't require me to copy large chunks of the more fully fleshed out version of this as well and explain all of that. So I'll just avoid that for now. So we'll be able to say things like, known, so we can say, parent, John, Jill, known, parent, Frank, John, right? And then we'll be able to say things like known, ancestor, and known ancestor, if parent A, B, and ancestor B, C. This is basically, what I'm going for.
So if anybody who hasn't actually looked at Prolog Holiday, especially within the context of Lisp, those question mark variables are your logic variables when you're defining. And what he
There's actually this
go ahead.
really neat little thing here, which is that Screamer comes with this neat function called template, which takes a list where some of the things in it are, XYZ, as, and some logic variable, x, and it replaces that x with an actual Screamer logic variable and returns an A list of the substitutions it made, which is really convenient.
Nice.
Because it means that I could basically use this exact syntax here without having to parse it or anything and come up with a bunch of lists containing, Screamer logic variables. Makes my life super easy.
I mean, this is kind of neat. So you're using the same macro to effectively define your rules too there.
Yes.
Okay.
Yes. Yeah, because this thing is simple enough that there's no point bothering to distinguish all that nonsense.
Right. Because I think I remember, the first time I went through, I think it was Allegro Prolog, I had to remind myself what the difference for defining a rule was versus setting a fact in.
So
Isn't a rule the same as a fact, just the rule has a body?
Yes, but some Prolog systems require you to define them separately for optimization purposes.
Yeah. You also have an arrow, you use an arrow syntax where if you're doing back propagation, where you're saying this logic variable infers from these sets of rules. I can't think of one specific example right now off the top of my head.
Anyway, here's our implementation of known. It's really, really simple. It just stores the rule in the database.
That's it. But that is known, right? That's technically known, right? I mean, if it exists, it's in the it's in the database.
Okay. So we're going to define this other function called show, and it's going to take a list of requirements. First thing that it's going to do is it's going to require that those requirements, so it'll vars. It is going to template those requirements. Do I want to do that here? No, there's no point templating that out here. I'm slightly tweaking this from the version that I've got written elsewhere, because that version involves two mutually recursive functions, and that causes problems with Screamer because it likes having the functions be defined in order for a variety of reasons. And so I'm trying to, on the fly, rewrite this to use a single recursion. You can't easily use regular loops in Screamer. This is one of the sort of flaws that it has, admittedly. Regular loops play weird with backtracking. Backtracking back through a loop causes weirdness. And so if you really want to make sure the backtracking happens properly, you have to use recursion. So anyway, what we're going to do here is we want to, the idea is our show function here is it's going to take the first requirement off our list of requirements, right? It is going to assume it's been passed an already templated list of requirements. So in our query macro here, we're going to have to template whatever query the user gives us. And so it's going to take this list of requirements, which is really just a list of forms like these. And it is going to, it'll operate on the first one in the list, and it'll recursively handle the rest of the list. And what it'll do with that first one, so, rec is carve rex, and I'll insert a proper guard there in a minute. And what it'll do then is it's going to, we are going to pull out a rule from the database. Rule is a member of our database. I pick one of them, and we're actually going to template that. And then what we're going to do is we're going to assert equal v. So equal v is kind of fun. Par of rule. So equal v, basically, it takes two cons trees, right? So there could be lists, or there could be lists of lists, or whatever, that contain values and variables. And when it has values, it's basically the same thing as equal. It compares them for value equality. When it's variables, it constrains those variables to be equal. And when there's a variable on one side and a value on the other, it does an assignment. So basically, this takes two cons trees, and it makes sure that any variables in there are constrained to match the thing on the other one.
So, question here regarding that template a member of. Now, how are you distinguishing between facts and rules here? Because it doesn't look like a member of would be able to know
It is not.
Okay.
It is not distinguishing that at all.
All right. Just want to make sure that I'm not misreading that. Okay.
Actually, as far as this is concerned, this Prolog does not know the difference between facts and rules.
Okay.
This Prolog simply will not bother with that distinction at all.
All right.
A fact is simply a rule. It doesn't need to do further work to prove.
Excellent.
Quick question: Is your db global variable there actually available in the macro at compile time?
No, it is not. Thank you for reminding me that I need to actually make that an expansion. There we go.
Better.
Yes. Now that'll do its job. I could even cons that at compile time properly, probably. And save a little runtime computation there. Anyway, not that really matters anyway, because that's a defining form, and so... Anyway. So we have, this assert here, and then basically what we need to do is we need to show any of the requirements of that rule, which are just the rest of the rule. And then we need to show the rest of our requirements. I think that's it.
Wow.
So does this make sense to you? So we give it a list of requirements, right? We pull the first requirement out. We pull one of our rules out. We template it. We assert that the first thing in that rule can be made equal v to the requirement that we're trying to solve for. And so that will make sure that, the cars of the lists match, right? Which means that we've got a rule that actually could possibly handle the thing we're looking at, right? And then it'll assert that they're of the same arity, right? With the same number of things being passed in,
right?
And it'll constrain the variables that we've just templated together to equal whatever the thing in our requirements is, right? So that assertion will take care of all of those things for us. It'll find us a rule that we can use, and it'll make sure that our variables are properly constrained.
There's a question in the chat. Why use let star instead of let in?
Oh, there's no reason. I thought I would need to use it, and I don't.
Yeah.
Thanks for pointing that out. I thought I was going to need that. It turns out I didn't. Anyway, so I'm pretty sure this is literally it. In fact, I think I could do that and save myself a local.
That actually makes sense.
Yes.
Interesting.
So your 10 lines is actually 5.
Yes. Yes. There. Well, we have
Prolog, everybody.
we still have to write the query.
We
right?
haven't finished the query yet. We still haven't finised the query
Yes.
yet. So the prologue isn't done yet.
So we need to get one value because we need a non-deterministic context. Then what we need to do is we need to MVB our way to templated and vars. We're going to template whatever the user gave us. I'm going to wrap that in a list command. There we are.
So question here. It looks like the fact that you're using multiple value bind. What are the multiple values returned by template? Like
They're right over here.
Oh,
they're the original list templated and an A list of the variables and their screamer variables.
I didn't notice that. Okay, got it. Thank you. Sorry.
Then we need to show our templated thingy, and then we apply substitution our vars. Ta-da!
Wow.
Now, technically speaking, if I was being good, I would gensim temple and vars. So let's do that. Temple is a gensim templated, and vars is a gensim vars. Good macro hygiene, everyone. Always practice good macro hygiene. Right, and so now we can query. We just show that all of our requirements are satisfiable, and then now that that's assigned values to all of our variables, we substitute those values in for all the locations where our variables are in this, A list of variable name to streamer variable that we have, which will get us a nice A list of variable name to the value that it was shown to be. And so now let's go ahead and just load this whole file. And it failed. It failed horribly. It failed horribly. What did I do wrong? Expand that. Oh, do you guys see it?
Yeah, because you have an extra set of.
I needed. I need to quote that.
Yeah.
Okay. There we are, compiled and loaded without warnings. So now let's query something. Let's see. Is Frank
baked and roasted some chicken?
an ancestor of John?
Frank? Oh, you have to maybe specify them.
Oh. Now it should quote those. What am I doing wrong? I'm doing something wrong. Oh, I need to quote that. Look at my database. Okay, well let's first do parent. It doesn't like that for some reason. And I don't know
hold
why.
on, go back to your database. It looks like there's a list here, a list of lists, parent, empty.
Yeah, there would be lists of lists. It's entirely possible I've done something really stupid. That is entirely possible. Print rule. I have code that's very similar to this that I've used in the past. Let's see. What am I doing wrong? I know that this is... Admittedly, this exact way of writing this is something I've not actually tried before, so it's entirely possible that I've just got a flaw in my
Can you
logic.
macro expand your query?
Sure. Let me roll that over to a buffer over here so I can...
Comma MS. Okay.
I'm not going to macro expand it any further because you guys will yell at me. Post CPS code is fun to look at. Let's say that. It's fun to look at. Okay.
I think it has to be associated with your show.
Oh, God. What am I doing? There.
Oh wait, you have to splice it still,
No,
right?
because it takes a list.
Oh, okay, gotcha.
Right? Because it's taking a list of things, it is templating them, it is showing all of those things, right? So like if we print pull, we see quite in fact where our list of requirements, parent Frank John, because there are no variables here.
Right.
Do you have to quote put a quote in front of the comma there?
Shouldn't need to, no. That would just get me the variable there.
But it's saying that you can't backtrack, so I'm assuming it's a problem with the show function itself. Right?
Yeah, I'm almost certain that that's the thing. There's a problem with the show function. I just don't know what it is.
Well, the only thing that would force the backtrack is the assert, right? So.
Oh God, I'm an idiot. When Rex, I told you guys I was going to add a. I was going to add a bounds check on that eventually, and then I never did.
Yeah, there we go. Much better.
You could just return nil. That is what it's supposed to do.
Right.
Right, because there weren't any variable assignments to be made. But we can ask who Frank is the parent of.
So.
John.
John. Nice.
Yes. And
who's the ancestor of Frank? So that's actually cool. Yes.
Perfect. And let's see, who did I say?
John should also be an ancestor of Joe, right? So you can.
Yes, I don't, however, have an all values query. So let's write that now. Called that query star. My other code example. So, in my other version of this, be similar. It pretty much does the same thing, except it's an all values instead of a one value. You should just copy that.
So technically, you could refactor that so that it's you could pass in fun. You can do a fun call to that, right? To
all values?
To one value or all values, depending upon.
No, because they're macros.
Okay.
I could pass in the symbol. I could do. Actually, that's not a bad idea. That's a really good idea. I'll call this way. And now, all values. That did not work.
Did you compile? Did I see that compile? Don't know. Wait, you said Frank. Oh, wait, that's right. No, that's right because that's Frank. Frank and John say ancestor, right? You have to say,
yes, you're right. Yes, thank you. Ancestor. There we are.
There we go. Yeah, that's right. Oh man, that's good. That's much cleaner too. That's actually so now you're specifying. I only want one or all, and it's makes things a little bit.
And what's really cool is this. Yes.
Nice. Yes. Done.
Because Screamer has that built in. So there. That is Prolog in this many lines.
Man, that's so cool. Okay, I'm gonna have to play around with this library a little more.
Now, this Prolog is stupidly slow.
Yes, of
I will
course.
tell you that now. I have written slightly more optimized versions of this and hard-coded in handling for certain predicates, right? And even then, it takes 20 seconds to solve the Einstein problem.
Ouch.
Even using an optimized query, which I took quite a while to find the most optimal way I could set up the rules and the query for that. It takes 20 seconds to solve Einstein. If you don't use an optimized one, it will just spin. Spin, and it will spin, and it will spin, and it will spin. So yeah,
wow.
it is stupidly slow. However, it's just really cool that you could just do this. You could just make that work, and it just doesn't. And this doesn't preclude writing a proper compiler. I just am too lazy to do that because it would require me to re-implement pattern matching. And I don't want to re-implement pattern matching.
But for some very small use cases, some very small, I'm not saying very huge, usually ends up, this works. I mean,
So the thing is, there is actually a proper logic programming library for Lisp, something that's like actually designed to embed a Prolog into Common Lisp. There are a few of them designed like properly for performance, and like anything you can do with this, you can just do with the straight Screamer API. It's just a notation that doesn't have as much nesting. Like really, when you get down to it, this is really just an alternative notation for the same thing we were doing with the logic variables earlier. It just doesn't have nearly as much nesting. And so, like, you can, and it's much faster, as you saw, to just use the logic variables directly and not. The thing that kills it is this right here, the equal v. That kills it, because it's the combination of the template and the equal v, right? Because what that's doing is it's creating a whole bunch of spare logic variables that then get constrained and thrown away. Tons of them.
so template and equal v generates a lot of garbage that potentially...
It generates a lot of constraint variables that you don't actually need to solve the problem. They purely exist to be constrained to be equal to other constraint variables.
Gotcha.
Right? Because, like, you know, when we template this rule here, right? We template this rule, and it creates an A variable, and it creates a B variable, right? And then we pass in a requirement, which is like this, and now that question mark gets constrained to be equal to that B. And that B now didn't need to exist. It does exist. It's an independent variable. It's just it's been constrained to be exactly equal to whatever this question mark is. And when you get into really, really big, you know, queries and really complicated rules, you're generating, you know, extra variables all over the place. Variables that only exist to be constrained to be equal to other variables. And Screamer even has special handling internally for variables that you've said are equal to other variables. It has rules for making that reasonably efficient. And even then, like, I'm generating literally thousands and thousands of spare variables when I run the Einstein problem. And that soaks up all the time. Yep. So, you know, if I implemented a compiler, I could probably go from this to code that is as efficient as what we were seeing earlier, right? If I implemented a proper compiler and a proper pattern matching syntax and all of that nice stuff, but I'm lazy, and I have other things to do.
Right.
I actually tried to be super lazy and just steal the trivia pattern matching compiler, but there's a flaw with that, which is that Screamer's code walker doesn't know how to deal with symbol macrolet, which maddens me, and Trivia, for reasons that also madden me, uses this extra symbol macrolet that doesn't actually do anything in 99% of use cases, but it's there in every single expansion of the macro. And so you can't use Trivia with Screamer because it happens to use one of the things that Screamer doesn't know how to deal with. And the dev for Screamer hasn't fixed the code walker to handle that.
So, I'd be curious. Like, you could tweak the code walker for Screamer,
Yeah. There's no reason Screamer's code walker couldn't support that.
Okay.
There is no reason it couldn't support that. It just doesn't.
Gotcha.
The library has a flaw. There are actually, I think, three or four. They're listed in the docs in big bold letters. They are right here. These ones. These are the special forms that aren't handled by the code walker. Load time value, macrolet, and symbol macrolet are the ones that it can't handle at all. And it can kind of handle prog v, unwind, protect, and catch, but the bodies of those become deterministic. Similarly, flet and labels functions, local functions, while the body of the flet and the labels itself is non-deterministic, the local functions have to be deterministic functions. So you can't create a non-deterministic loop using a recursion involving f-letter labels. So there are a variety of just little constraints on the code walker that make writing code a little bit like walking on glass sometimes, and that's one of the reasons why Screamer annoys me. Because it is a really awesome library, and it shows really the power of what you can do with just, some macro magic and some trickery and, some ideas about how you want to change Common Lisp to suit your, stuff. But it doesn't handle everything. It, like every other Lisp library out there, it handles the 80% of things that the person who needed it for.
Well, folks, pull requests are welcome.
Yeah. Though it is a mess of code, it is a whole lot of code because code walkers kind of need to be.
This has been a really, really nice tour. Thank you so much, Elijah. I mean,
yeah. No, I'm perfectly happy to walk people through libraries.
This is, I mean, especially the Prolog one. That's the simplest I've seen.
Yeah, well, I mean, I basically have stolen a whole lot of stuff from Screamer specifically designed for this thing, right? Like template and apply substitutions, right? And actually, if you go down to the docs on equal v, it actually tells you in no uncertain terms the expression assert equal v is analogous to Prolog unification.
Okay. That alone tells you how performant it's going to be.
Yeah.
Oh, man. No.
Yeah. And you even have not v equal v, which is the Prolog 2 disunification operator. But that's for another day.
Yeah, absolutely.
But yeah.
That's cool. Well,
yep.
So next you can walk us through his other library, SBCGA, which uses SIMD instructions and defines VOPs in SBCL.
Oh yeah, that'd be fun.
Actually, I think when we start talking about VOPs, I think it would be interesting to talk about VOPs, and I think Closure CL has something similar. I'm forgetting what the name of it is though, to actually define like instructions to do the code generation. But that's now VOPs we're talking about. Fun. That's all Lisp implementation specific.
Yeah, that's SBCL. Oh. I have had some fun with VOPs. I have. There's an example on one of the SBCL developers' blogs. I forget which one offhand, in which he implements a really, really stupid stack-based architecture. Or stack-based VM that actually stores the stack in registers, and so you only have an 8-deep stack, and then it loops. But he actually implements it natively. He uses SBCL's assembler to generate code for his VM, and then he implements a VOP, which compiles, which implements a call to a particular function as actually jumping to the entry point of this VM, and then has the VM return back out to Lisp. And so you can actually then generate code and then run this VM, and it's just running natively, and then it returns back to Lisp. And it actually kind of works even with backtraces because SBCL's debugger actually inspects the stack at runtime properly, and it even has some weird kind of handling for foreign code backtraces, which almost sort of works. And it's just kind of cool that you can just do that. You can just be like, hey, I want to generate some x86 assembly. Hey, SBCL assembler, will you help me with that? And then you can just generate that and stick it in a code page. And then he makes a POSIX call to generate a code page that is protected to be executable. And then just literally just jumps to it.
Ugh.
Anyway,
So
topic for another day.
that's definitely a topic for another day. Thanks so much for all of you guys for joining us. We right now I'll announce the next week's topic on our local channels, but until then, I will see you guys. We'll see you guys next time. I hope to see you next Monday. Remember, next Monday from 5:30 to whenever. That's-
Okay, thanks for another very interesting one.
Yeah, thanks. That was very, very interesting.
Sure.
Thanks so much, guys. See you guys later.
Oh, check YouTube chat. Yeah.